Welcome back to Black Alert. In today's tutorial, we're going to talk about how to create an AI agent or just an AI call via the followings. We will create a Gemini AI client. We're going to host that into a Lambda function in AWS and host that agent behind a RESTful endpoint. That RESTful endpoint will be powered by AWS API gateways. For the simplicity and for making this as quick as we can, we're going to cover the Lambda function, we're going to cover the deployment and automatic deployment, and we're going to cover the infrastructure that is managed by Terraform. So in summary, it's going to be a Python code hosted in Lambda function, an API gateway to trigger that Lambda function, a Terraform to manage the code or to manage the infrastructure in AWS. The requirements is an API gateway, an API key for Gemini. I will drop down all the links to get an API key from Google Studio, and I'm gonna drop the Gemini documentation. And for this tutorial, we're gonna use the newest Google's LLM module, which is Flash 2.0, and as usual, Terraform with AWS provided the latest to cover all of these. First of all, we're gonna start off by creating the infrastructure. Then we will create the code. Then we will deploy that code to the Lambda function. Then we will trigger the API gateway via curl command on terminal or via Postman if you have one. So first of all, the usual, we're gonna go to Terraform, and we're gonna head to the provider, Terraform provider. The current Terraform provider for now is AWS. The version is 5.82.2. I'm gonna use PyCharm as an IDE. I just did a demo code before I did this tutorial just to make sure everything is working smoothly, so we don't have to waste time on debugging the code. I'm going to host the entire code, the infrastructure, and the Lambda function here in the same directory. So I'm going to head there and create an infra directory. Inside that infra directory, I'm going to create a main.tf file. This is going to be where we host our Terraform module and initialize the Terraform. In here, let me just install the plugin really quick. As you can see, we are initializing Terraform, and we are adding a provider which is AWS 5.0. With this indicator means that we're gonna use the latest version. Our region is gonna be Middle East Central 1, which is UAE. Central 1. Central. Central 1. And since I'm using multiple AWS, and it should be BA. Okay, now we have Terraform ready. We can just open our terminal. We can cd the infra directory, and we can run them Terraform initialize to initialize our provider. Now we're gonna need two resources to make our example running. We need an API gateway, and we need a Lambda function. For that sake, I do have some previous code that I'm gonna use. They are modules that I've created previously, as you can. To have this, I'm gonna describe what the modules are doing, and I'm gonna tell you exactly how we built them. So I do have a Lambda module which is ready. I do have a repo variables deployment because we will deploy using BitBuckets. GitHub will work, but for this tutorial I'm gonna use BitBuckets. And we need an API gateway. These are predefined modules that I already have. So in our infra, I'm going to create modules directory. I'm gonna copy these, and I'm gonna walk you through each one of them. So for the API gateway, we are creating a RESTful API. We are creating a resource, and we are creating a method. For our case, it's going to be a post endpoint. Of course, we're going to manage course in here, so we're going to add the course options HTTP method, and we're going to allow some headers, and we will allow our API gateway to trigger the Lambda function that we are using. Sorry. There are some responses. We want to make sure that our API gateway will respond with a status code of 200 and a JSON body that our function will return, which is the Lambda function. Nothing too fancy in here. Course management, an API domain to manage the certificate, to manage the domain of that API gateway. And we're going to output some variables from the module, and we will have to pass few variables to make our module work. This is for the API gateway. For the Lambda function, we are creating a Lambda function. It's highly customizable. I'm gonna push this code to GitHub later on, so you can just review the modules, Terraform code, and you can review the Python code that we're gonna create. So it is just a Lambda function and an S3 bucket to host the zip files where we will do the deployments. We're gonna output the function name, the ARN, and the invocation ARN that we will use later on with the API gateway, and we are passing a few variables to the function as well. For repo variables, I'm using BitBuckets provider, and in this BitBuckets provider, I'm just checking the workspace and the repository that I'm going to create. Then we manage deployments, and we manage pipeline variables in there. So when we do create the deployment pipeline in BitBuckets, that will take the code, zip the file for us, push it to the S3 bucket, thus update the Lambda function with the newest code. Now, that's it. The Terraform is ready for now. Let me just run Terraform initialize again. Let's add the BitBuckets provider to our main TF, just to make sure that we do have all of them ready. Now, in our infrastructure, we will do a REST API, the TF file. Here we will add the definition for our RESTful API. I do have an old code that I'm gonna just copy paste. So in order to create an API, we need to use this code. We're gonna just call it API. We need to define a variable. It's called the API's domain. We're gonna do a default. We will use a domain that we already have. I guess we do have blackalert.agency, which is the blackalert domain. There's no need for production for now. We're gonna use dev only, and we're gonna call this APIs. So we need to add another variable for our AWS account. And we're gonna define default, and we're gonna give the dev environment, or the dev environment of AWS account, the account number, and we need a zone. We're gonna use a predefined zone in our case. So we're gonna call it blackalert zone, and we're gonna just pass the existing domain name, as you can see. I'm gonna put it here. Now, so this one, we're gonna call it chat as the endpoint. It is a post request, and we need to define a Lambda function. So lambdas.tf, we will define a Lambda function here. For that sake, I'm just gonna copy one of the definitions. Of course, they are using the modules that we have created. We're gonna call this chat AI Lambda. Call it AI chat Lambda in here. There is no need to pass any environment variables since we are not using one. Sorry for that. We need an execution ARN. It is an IAM from here, a module that we have previously defined. It's going to create the policies and an IAM policy for our function. It's a dynamic one where we pass the basics of how we allow services to trigger our Lambda function. And here we're going to copy paste this, and I'm going to keep it here. IAM function, we're going to call it blackalert Lambda role. We are just passing the basic execution role here. And for deploying the lambdas, we have to use an old module that we already created to create S3 buckets as well. It's just a function that creates a bucket for us and gives some permissions to that bucket and so on. You can review this code later on to see how we do it. So it's gonna be a storage as well. Now we have to run Terraform initialize again so we can get rid of these warnings. We have to move this to infra. That's it. Okay, so now we have a Lambda function. We have a bucket to host the new deployment files, which is the storage files. Blackalert demos. And we have an IAM rule to manage the Lambda function. Now we have a RESTful endpoint. We will pass the Lambda function. And we call it blackalert AI function. We will pass the Lambda name and the invocation ARN. Now we are ready. We'll call this blackalert API. blackalert, and yeah, so the last piece of the puzzle that we have to create a BitBuckets repository, and in this BitBucket repository we're gonna pass it to Terraform, so we have one source of truth to see the deployment variables, to see the environment variables, and to do everything that is related to the project. Now we can do this in blackalert. We can call it AI chat agent demo, and boom, we have it ready now. So we can create a file, we can call it repo vars.tf, and let me just copy paste an old code from here. Repos, this one for example. So this is the blackalert alert lambda repo variables, and in here we have a workspace, which is our workspace here, and you will have to pass the repo name from here. We have to create a user for credentials, where we do allow that BitBuckets repository to manage the deployment for us in an AWS account. Again, I do have the users, I guess here, AWS users file. I'm gonna copy paste that. It is just a resource to create an AWS IAM user or a user for deployments, and it has an administrator access for now. That's it. We do have to get the region, which region we are working on. We can just pass this as the region name, or we can just use the default that the provider is using. Data AWS region, and we can call this current, and now we have the region ID, which of course equals ME Central 1 or US East 1, depends on what your provider is using. Now we will pass the Lambda function name and the bucket where we host the zip file for deployment, and the function name, and that's it. So let's do a Terraform initialize again. Wait for it. Cool. Let's do a Terraform plan to see the actual plan and to see what resources are going to deploy to our system. We missed the account here. Let's just bring the account. You can find the account in here. This is the account ID. Just copy this, paste it here, and that's it. As you can see, there are some warnings here because we are using a Terraform workspace to manage multiple environments in here. So for example, you may have a dev environment, a production environment, or a staging environment. So we need to create that because I'm using Terraform workspace to manage the environments. I do have only the default. So for that, I'm going to create a dev workspace, Terraform workspace new dev, and now we have a new environment. If we list it, you can see that we have a dev environment, we have a default environment, and it is marked in here as dev. Now, if we run Terraform plan again, you can see that we will see the actual plan. Our domain is existing here. We don't have to create a domain via Terraform because we do create that manually in our AWS account to just persist that hosted zone, because we do have a lot of things to be managed. So we did fix that. As we have providers inside the modules, we need to pass the profile or just export the profile here. You can use a command export AWS profile equals the profile that you're using. For our example is PA, or you can just pass the profile directly here in the providers that you're using. We do have two in modules providers, which is one in storage and one in the API gateway, so I had to add both of them to make this work. Anyways, now we do have our plan working, 45 to add, which will include all of our resources. To apply them, we can type Terraform apply, and we can pass the apply auto approve, just to do an automatic approval on the plan that we just saw, because you are okay with that. As you can see, it's going to take some time. In the meanwhile, you can see that we do have a domain that will create an ACM certificate for us, an API gateway, a Lambda function, and a storage with 3 bucket storage to host the deployments. And we're going to manage the BitBuckets repository via Terraform as well. We're going to see some information from Terraform code. Thus, that will give us a successful deployment. Now, if we head back to our AWS account, if we check S3, now we should see a resource in there, or an S3 bucket, which is, as you can see, the storage. This one is created 4th of January. It's today, and it is ready. We should expect one file inside, because when the Lambda deploys, there should be a file. As you can see, it's the Lambda default code, which is a zip file that I'm pushing from the Lambda in here. Lambda code, and this is the default code that goes to the Lambda function, because AWS will never allow you to create a Lambda function via Terraform without pushing a default zip file. If we go to Lambdas now, in UAE region, because we are in UAE region, you can see the Lambda function. They're ready, and it should be connected to an API gateway, as you can see. Now you see the code in here, which is the default one that we are pushing. Now we can just call this right away to see if the Lambda function is working. So if we let's change the username, and here demo. Let's apply again. Either you can delete the old one, or just create a new name that will create a new user for us. If we head back to the APIs, REST APIs, you can see that our domain is APIs. So I'm doing a GET request while it is a POST request. It's not a GET request. Let's do this. Let's just create a request. This request is gonna be POST. Yeah, as you can see, the Lambda function is working now. In Postman, you can just pass it here, define as post, and that will trigger the function. What the Lambda function is supposed to do, or supposed to return for you. Now, for ready, and we do have the repository variables in place. What is left now? We have to create our deployment. For that sake, I do have a deployment file. I'm just gonna copy paste that, and I'm gonna just open an old one, copy the ignore and the BitBuckets pipeline. Just a second. Yeah. Copy. You can go here, paste this, and let's initialize a GET repo. Let's do our remote, which is the repo as well. Manage remotes, and a new remote. Done. That's ready. Let's go now and do an initiated commit to the main branch. Since we are on dev environment, all of the things are connected to what you have in BitBuckets. I'm going to show you that in a bit here. If you checked, we are running a pipeline on dev branch where we use the deployment of dev, the one we seed from our Terraform code, this will read which account we are using, which AWS account we are triggering, and where we do that. Which large files? Hold on. Let's do a reset. We have to exclude Terraform from here, so let's go to our BitBuckets and let's do infra. Let's go back here, refresh. Alright, now let's add them again to an initialize push. We have 5 files here. Let's refresh. So as you can see, now we have the code. We have our main branch only. Let's create a div branch and do a new push. So we will have both codes synced in our main branch, which is of course the production environment that you can use or you can push to when you have your production ready. Now, if we do a refresh again here, you can see that we have dev and we have the main branches. So for the repository variables and the deployments that we did push from Terraform, we can see them here. If you go to settings, deployments, you can see the dev deployment in here, and you can see all the information that we are managing from Terraform code, repository variables as well, and our code is ready to deploy. Now, since we do have the BitBuckets deployment, basically what I'm doing is let's create the requirements.txt and we will add our packages in here. So we are just installing the zip. We are installing what is in requirements.txt. We are adding them to the code file. We are adding the Lambda function code. Then we will push that as an artifact from this step to the next step. Then we will do an AWS installation, and we will use AWS Lambda with the credentials that we are seeding from Terraform to deploy this code.zip file, then update the Lambda function with the new zip file. So this is our deployment. As you can see, it's only triggered on dev branch. It builds and deploys, and that's it. Now, what's left? What's left is the Lambda code. Please notice that the file name must match what do we have in here. The Lambda actually expects a runtime or a handler to be a Lambda function.py file and a Lambda handler inside. So this file is actually called a Lambda handler, which is wrong. Should be Lambda function, and it will trigger the Lambda handler inside the function. So we're going to do define Lambda handler. We will pass the event and the context, and that's it. So just to make sure that the Lambda function will be triggered, okay? I do have a code. I wrote a code before this tutorial just to make everything smooth and clear. What do we have to do? We do have to have the Google Gemini installed, and we do have to have the environments to seed environments from the system. As I do have an environment in my local machine, I'm not going to push that, so I'm not going to use this in production mode. Rather than that, I'm going to push this key via Terraform to the Lambda function. How we can do that? We can do environment variables, and we can pass this as an environment variable for me, I'm using this key. I'm gonna delete it, guys, after this tutorial. Anyways, just to teach you how to do that. Of course, it's not like the high secure way to do this, but if you would like me to tell you how we secure environment variables and sensitive data, and how we can push it into the repositories and into the lambdas without exposing them via Terraform, just write me down in the comments, and I will be happy to tell you how we can secure the environment variables. But for the sake of this tutorial, keep it simple. We are just gonna pass this as it is. No. Now let's do Terraform initialize, and let's do Terraform apply auto approve. Now, if we head back again to the Lambda function, to the configuration side, environment variables, as you can see, we have none. But after this applies, we should see the code applies this for us as a Gemini API key. As you can see, if we do a refresh again, now we have it as an environment variable. Then let's go back to the code. We'll only use Gemini to know how to install it. Let's go to this and copy the package name, add it to our requirements.txt. To install it locally, you can of course do a pip install Gemini and you'll be ready to go, just for local testing. But for our Lambda function to use it, we're gonna add it to requirements.txt and it will take care of it. Now, we no longer need this. We're gonna import these into our Lambda function. So here, and we're gonna get the process chat. I like autopilot. Let me just copy paste this instead of wasting time. Now we do have to import it's from Google, import Gemini. This is how the API should be initialized. For that, you can go to the documentation and see how they are using it. I'm just following the documentation. It is the multi-turn thinking conversation, or just the streaming thinking, or calling the API to get content generated for you, or chat ready for you. Now let's import the async IO, and our code should be now ready for that. Let's go here. Let's add these and deploy code, commit and push. Now let's head back to our repository, to the pipeline section, and within a second we should see the pipeline running. If not, it is running. If not, for the first time, you can just trigger that manually by run a pipeline, this button here. But this is deploying the code. What it actually is doing is building and packaging the project, installing the Gemini library for us, which is a requirement.txt, as you can see. So it's collecting Google Gemini for us. This step is ready. Now we're adding every dependency to the zip file, and we are uploading the artifact. Now we are pushing the Lambda function code to an S3 bucket. Then we are updating the Lambda function to have the recent code. Again, if we come here to the code, we still have the old code until we get the deployment ready. Let's just wait for that for a second. Now to try that, what we are expecting a message from the event as a JSON body to me who you are. And now we have the file uploaded to S3. It is just updating the Lambda function with the required or with the new deployment, which is the new code. Yeah, now it's ready. Let's go here, refresh again. So if the package file is big, and which I'm expecting, you cannot see the editor here, but it's fine. If it's not big, then you can just see the code that we have created. As you can see, yeah, it's not big enough, but the Lambda function code is already here in the Lambda function. Now our Lambda function is ready, the code is ready, everything is ready. We can just go to the Postman again and send the request, and we should, yeah, as you can see, we have the API response, which is we have the code deployed. Actually, I had to add few error handling and some boundaries to make sure that the code is 100% working. It is here. I forgot just to load the JSON, or to load the text from JSON, then extract the message element from the JSON, then pass it to the chat, and then return the response. Now again, if we come back to Postman, if we trigger this, I'm a large model by Google. Where is the largest city in the world? I have no idea what's that, but let's just ask them to see. Why it is slow? Because this is a Lambda function, and Lambda functions had a cold start where it has to initialize for you and get itself up and ready. Then you have the latency to call that LLM, and you have the response and the network latency between your connection and the API gateway. All of these factors give you around 10 seconds for executions. For deploying AI agents and real-time chats, I don't recommend go with Lambda functions, but if you're interested, just write me down in the comment and I will be more than happy to tell you and design a diagram for you and do a real-time implementation for how to do a really fast, really instant, good chat agents and chat systems or LLM integrations with Google Gemini. That's it for the moment. Diagrams will be attached with the demo. If you are interested in more information, if you would like to ask any questions, please feel free to ask me here, or drop any message to our WhatsApp. It is attached. Our website is already in there as well. Thank you very much for watching.